So, hello everyone. I'm Alexandre Moreno from ACTALIA in France, and I will talk a little bit about the sustainability and environmental assessment. So, our main goal during this project was to assess, from an environmental point of view, the HPT process and compare it with other technology existing. And so, to make this kind of work, we use the methodology of life cycle assessment. So I will briefly present you what it is. So that's a standardized methodology which is promoted by European Commission, and it's called as the best tool to make happen the eco-transition. And so if you think about life cycle assessment, you have to think in a life cycle perspective. Of course, it makes sense. So in life cycle assessments, if you want to calculate your footprint or the environmental impact, you don't have to focus only on one plant or one area. You have to think global and to take into account all the life cycle of a product. So you can take into account the resources, so that means agriculture, food production in the case of the food sector, processing, manufacturing, distribution, use, and of course end of life. So in life cycle assessment, you calculate the environmental impact relatively to the functionality of a product. That's the main difference. And the last point is that a multi-criteria assessment, so you don't only get information on a carbon footprint. You can get other kind of indicators. And we calculate potential impact. So I present you the concept. So we collect a lot of data, like food composition, electricity, natural gas, and we process this data in order to build some boxes, some inventories of flow, and model that in order to calculate different indicators, same to life cycle impact assessment methodologies. And for these studies, we use climatic change, water depletion, eutrophication. So that's relevant indicators for the food sector. So here are the studies that we have performed during the project. So we have realized 4 comparative assessments and split it in 2 axes. Process axis, when we compare the different technologies. So a thermal treatment, an autoclave with a freezing and the HPT process. And for the ready-to-eat meal hacks, we performed three different assessments on a green peas meal, fish meal, and a tomato soup. And we try to compare different scenarios for each meal, one using the current thermal treatment and one using the new HPT technology. And the methodology that was used was ILCD 211 midpoint plus, which is the methodology that is advised by the European Commission. So let's take a look at the process hacks. So as I said, in LCA, you calculate the impact in function of the functionality of a product. And here, we calculate the impact per ton of meal treated. That's very important. And the boundaries, so all the different steps that was taken into account are, for the HPT and thermal treatment and freezing, the raw material extraction, so with steel flow mainly. We didn't take into account the shaping of different pieces, the energy that you need to manufacture the processes, the machine, because that's data which are very complicated to assess, and so we prefer to let it apart. But we focus more on the use stage, of course, with the more important stage, and the end of life and the transport of the machine, even if it's a little bit insignificant for a process machine. And here are the results if we compare the different technologies. So first of all, we can see that for whole impact, HPT technology seems has to be a higher impact. But the main reason is because there is a too low treatment rate in comparison with others. But it's pretty normal because that's a comparison between very mature technologies and a prototype. So that's pretty normal to have this kind of results. That's why we try to make an alternative studies with expectation in terms of performance that we can get with a future technology of HPT machine. And so that's what we can expect and what we have modeled. So we can expect 10 times higher treatment rate, 3 times higher weight, 2 times higher water consumptions, and 8 times higher electricity consumptions. And what's the impact on the results here? So here is the current machine. You can see that's an higher impact. And if we take a look at the expectations that we can get, we have a closer gap between freezing machine impact and HPT1. So as I say, HPT technology has potentially the same magnitude of impact than freezing. And as you can notice, there is a 3 times higher impact for water resource depletion. But it's not only due to the water consumption of the machine, it's mainly due at 75% around from the electricity production. So let's take a look at the ready-to-eat meal hacks. So we perform three LCA here. For the green peas and the tomato soup, it was meals that was produced at Yarn Industry in Spain, treated by a thermal treatment, so an autoclave, stored at room temperature, dispatched to a distribution center and to different retailers, and transported by a lorry. And for the last case studies, it was a fish meal produced at Mafro in Netherlands, treated by a freezing treatment, stored at very cold temperature, sold to exports where it's consumed in the plane. And the main transport, it's refrigerated truck. So here is the boundaries for the ready-to-eat meal produced at Yarn Industry. So the functional unit here is 1 kilogram of ready-to-eat green peas and 1 kilogram of ready-to-eat meal tomato soup consumed in Spain. It's pretty the same boundaries here, but except of course the ingredients. And if we study an alternative scenario by using HPT technology instead of a thermal treatment, we just affect the step of preservation treatment on the overall impact of the LCA of the meal. And that's why we have this kind of results. So if we compare the different LCA for the scenario treated by an autoclave and the one treated by HPT technology, we can see that we have pretty the same results because the contribution of preservative treatment is very low. So it's too low to impact the results. It's around 2%. And the main contributor of the overall impact is of course the food production. So we can say here that there is no environmental benefits or disadvantages to use HPT technologies. If we take a look at the result for tomato soup, we have pretty the same conclusion. The contribution of preservative treatment is a little bit higher, around 8%, but yeah, the difference is it's very close here. You have a little bit more impact by using HPT technology, but yeah, it's the same conclusion. And let's take a look at the last case study. So on the left, you have the system boundaries for the meal treated by freezing. So in Netherlands, so it's a specific case in Netherlands. And on the right, the one treated by HPT process. So here we can see that you can have several benefits. Of course, you will affect by replacing freezing treatment by HPT1. You will affect the preservative treatment step, of course, by the consumptions, but you will affect as well the storage. You can get a chilled storage instead of a cold storage, and potentially you consume less electricity at this step. You can also affect the transportation because you will use a chill lorry and not a refrigerated one. And for the consumer steps, to heat the meal, you will spend less energy as well. So let's take a look here at the results. So for this study case, we can see that HPT technology has a lower impact, 5% less for climatic change, until 20% less for freshwater eutrophication and 5% less for water resource depletion. So yeah, it's essentially due to the fact that there is a high impact contribution of the cold storage in this chain of production, and so there is a high potential to reduce impact at this step. Because the preservative treatment, as we have seen on the process hacks, there is a higher impact from the HPT technology, but it's compensating by the lower impact that we can get with a chilled storage. So the main conclusion here is, for this case studies, there is a potential benefit to use HPT technology for meals when they need to be frozen to be stored, at a frozen storage. So thank you.